This is the first workshop for KCD Bengaluru, and it's on Kubernetes 101. I am Tuni Saha, and I am a second year student at Dhyana Sagar College of Engineering, and I'm one of the volunteers at KCD Bengaluru 2023. Well, KCD Bengaluru, it's the third edition of like KCD Bengaluru, right? Like the first two were online, and this year it's like the first in-person event, and all of us are very excited about it. And it's supposed to be on 2nd and 3rd June at Nimans Bengaluru. You guys can visit our website, KCD Bengaluru, and you can book your tickets from over there at tickets.kcdbengaluru.com. We have actually scheduled many workshops like in the days leading to the main event. It's going to be a 2-day event, as I've just told. It's going to be on 2nd and 3rd June, right? So yeah, like this is like the first of many, right? And yeah, today our host and the person who's going to be the keynote speaker is Abdul Karim, and he has about a decade's experience worth of like building and like shipping reliable, scalable, and secure infrastructure on cloud. Right? He has worked at Ola Cabs, and then he was a DevOps engineer at Browser Stack, and then like he shifted roles as a site reliability engineer at Trusting Social, and now he's the co-founder at Recursive Lambda. And he's going to take this hands-on workshop for absolute beginners, by the way, and he's going to be teaching all of us about how you can deploy and like dockerize a normal application in a local Kubernetes cluster. And yes, this is going to be a very fun experience for all of you guys who are absolute beginners at deploying and like basically containerizing applications. So please enjoy yourselves and treat yourselves to this expert that we have today amongst us. And yes, again, have fun. Abdul, over to you.
Yeah, thanks, Puneet, for that nice introduction. Uh, I think we have 14 people on the call. Should we wait for like 5 minutes for others to join?
Sure.
Or in the
We
meanwhile, maybe we can do some quick introduction with other folks. Guys, this is going to be an interactive session, so uh, turn on your videos, turn on your mics, and yeah. So there's a quick intro template that I have. Maybe we can use that. So yeah, I'll just quickly introduce myself. Tunir has already given most of the technical stuff. So hi, I'm Abdul Karim. I'm from Pune, and I work as a reliability consultant at Relambda. And in my free time, I like to read books and sing songs. Uh, so maybe we can just one by one go through quick introductions, and you can follow the same template. Tunir, how about you?
Yes, sure. Hello.
Yeah, just quickly introduce yourself, right? Just follow this template here, and then we'll go one by one, to all the participants. In the
Okay,
meanwhile,
yeah, sounds good.
others are joining. Yeah.
Uh-huh. Okay, so again, I'm Tunir. I'm from Delhi, and I'm a student, a second year student at Dayanand Sagar College of Engineering, and I like to code and also read books. Yeah.
Awesome.
All right, like guys, again, this is an interactive session, so you guys can actually unmute yourselves and like turn your camera on. Like,
Proper
so
Krishna. Krishna. Not matter.
Lakshmi, would you like to introduce yourself? It's fine. Others, you guys can continue.
Hi Abdul, this is Mohan.
Hey.
I'm based out at Coimbatore, and currently I'm working as a VMware engineer. And I love reading books and playing chess. That's all about me.
Nice. Who's next? Sangram?
Hi, good morning.
Hey, hi.
Sorry, I joined a little late. So I am Sangram Sahu. I'm working in EY as a DevOps architect. So yeah.
Hi, welcome to the workshop.
Thank you, Abdul. Thank you.
Who's next? Ashish.
Hey, hi, good morning, everyone.
Morning. It's afternoon, but yeah.
Yeah, afternoon, sorry, just 8 minutes. So
No,
yeah, I am working as a DevOps and cloud consultant as a freelancer out open in the market. So
awesome.
Yeah, most of my work recently has been on Kubernetes across vaults, secrets, managing and creating deployments, new infrastructure, old infrastructure, everything. So yeah, just going to have a refresher from this workshop now.
Awesome. We should catch up after the workshop, right? We are also into consulting. Yeah.
Sure.
Nice. Hey, Prem.
Hi, good afternoon. Hello.
Yeah, who's speaking?
Yeah, good afternoon. This is Lakshman. I am in
hi.
the role of project lead in State Bank of India.
Nice. State Bank of India. I didn't expect that.
Thank you.
Yeah.
Yes, sir.
Welcome to the workshop. Yeah.
Thank you.
Yeah.
Hello everyone. So I'm Prem, and I'm from Bangalore. So I work as a software engineer at a company called Techion. So I mean, I have heard about Kubernetes and all that, but haven't used it much. So I would be excited to see like what I can learn here.
Nice.
Hi everyone. Hello.
Hey, hi.
Hi. My name is Surya, and first of all, Eid Mubarak to all. And I am from Bihar, and currently staying in Bangalore, working on TCS as a system engineer.
Nice. Eid Mubarak, man.
Hi Abdul. I'm Rajshekhar.
Hi,
I'm
Raj.
from Hyderabad. I work as a software developer in Work Technologies. So I love reading books and cooking. And recently I started working on Docker. So I'm just curious how Kubernetes solves the problems, what Docker can solve. Yeah, that's all.
Cool. Hope you get to learn something.
Hey, hi everyone. I'm Bharat. Can you hear
Hi,
me
Bharat.
now?
Yeah, we can hear you.
Yeah, so joined a bit late. I'm working as a operations engineer at Shell Oil and Gas Company. So yeah, we are doing Docker containerization, and we're using AKS. Just wanted to run Kubernetes on our on-prem systems. So yeah, setting up the networking part and administration part. That's where I joined here.
Cool. I guess we have enough people on the call. Anybody else wants to just introduce themselves, or should we get started?
I think we can. Hi guys, this is Nitendra. I am one of the organizers for the KCD Bangalore, and like to welcome all of you on this first workshop with Abdul. This is going to be a very great workshop. I have known Abdul for a long, and I know what kind of work he has put up for this workshop. So I'm pretty sure that you're going to learn a lot. Of course, this is kind of starting point. There is a long way to go, but this would definitely set up the right base for you. And I'm pretty sure that you would love and learn a lot from this workshop. Yeah. Hey guys, over to you, Abdul.
Yeah,
Thank you.
sure. I guess we can get started now.
Yes, please do. Yeah. Just one more thing that maybe if you want to talk about a bit of a break, which we'll take if there is any break in between, just so that people are ready for that.
Mm-hmm.
I just want to.
Sure.
Yeah.
Sure. Cool. Fine. So this is Kubernetes 101 workshop. We are going to cover the basics of Kubernetes here. Not really advanced level discussions would be happening. So even if you are kind of new to Kubernetes, that should be fine. Let's quickly cover what are contents we will be covering here, and what will you get from this workshop. So you'll get basic understanding of Kubernetes concepts, maybe some hands-on, commands that you can use, probably some kind of a cheat sheet that might help you in your exploration of Kubernetes or maybe in your job as well. So there'll be hands-on demos and maybe some follow-through content that we'll be sharing at the end of the workshop here. Q&A, this is important because there are tons and tons of videos and materials available out there that kind of teach Kubernetes, right? But the importance of sessions like these is these are interactive, right? And you can get your queries answered. So feel free to kind of raise your hand and kind of ask any questions during the session or even after the session, right? That's going to help the community. So introductions, I guess we've already done introductions, so we can skip this slide. Coming to prerequisites. So there are some prerequisites to this session, although it is for beginners, but it's for beginners in Kubernetes. But even if you want to start Kubernetes, there are some prerequisites that you need to know, right, to make full use of this session. Familiarity with Linux command line interface is the required prerequisite. So you should be fairly comfortable with using the CLI. You should be able to navigate directories, edit files. You should have used commands that have multiple arguments, right? For example, Terraform or AWS CLI or some kind of complex command like that. Because we are going to see a lot of commands, and if you are not comfortable in this space, there are chances that you might feel lost. But still, this session is going to be recorded, and you can revisit it any time in the future as well, right? Apart from that, basic Docker working knowledge will be helpful. Although this is not required, this is kind of optional. But if you have done Docker run, Docker PS, Docker build in the past, and if you kind of know the difference between a container and an image, that is really going to help. But again, this is not required. This is an optional criteria. Okay. And finally, there are some local setup prerequisites. So Nipendra had already shared this link over email, and I hope you guys must have gone through it. So we just quickly go through the local setup prerequisites. Interesting. Interesting. And my video is working, but GitHub is not able to load this. I'll just open it on my local machine here. Latest on. Can you see my editor?
Yes.
Okay. Awesome. So the local prerequisite should be you need a Kubernetes installation on your machine, right? There are multiple ways to get it done. You can directly do it via Docker desktop. So if you have Docker desktop installed, you can just go to settings, and in settings there's an option for Kubernetes. You can enable Kubernetes, and it will ask you to restart after that. So this is the easiest way to kind of set it up. And if you have done it already, then you're all good to go. If not, you can also use Minikube. I have added instructions to install Minikube on macOS and Linux, and also start a cluster. Right, Minikube start command will basically start a cluster. And if not, you can also use a Kubernetes through your cloud provider. But I would suggest that if you are new to Kubernetes, then skip this part. If you've not already done it before, try to go with option number 1 or option number 2. Right. Other than that, this is the repository where we have all the course material. So it would be good if you can clone it in your home repository, in your home directory, right? Just git clone. And if you want, I just share the link to this file so that you can set it up while you're going to the intro slides, right? Docker login, this is optional. I'll just do a quick recap of Docker, and in that I'll be pushing a Docker image to dockerhub, and this will be required for that, not for the actual Kubernetes part. This is completely optional, but good to have again. And then finally, there are some verification steps. So there are 3 commands that you need to run, and if you are able to run it successfully, then yeah, your local system is kind of set up properly. Going back to the slides. Yeah, I mean, before we start, there are a few questions, and you can just give a thumbs up if the answer is yes, right? So have you used Docker in the past? If you have used Docker, just give a thumbs up in chat. Okay. Just 1. Okay. 2. Oh, nice. Cool. So quite a few people have already explored Docker. That's a good thing. Have you explored Kubernetes? It may be in production, it may be on your local machine, it may be for development, some course that you have done. Okay, so no Kubernetes. No Kubernetes. No Kubernetes. No Kubernetes. Nice. So most of you have kind of used Docker, but fairly new to Kubernetes. Cool. And do you have Minikube installed on your local machines? Do you have a local Kubernetes setup? No. Setup in Docker desktop. Nice, nice. Docker desktop. Okay, it looks like Docker desktop is pretty popular. Cool. I guess we are good to go. And anytime during the call, if you want to ask anything, feel free to raise your hand. You can raise your hand. There's an option in Zoom, and we can basically stop the discussion and kind of answer your query. Cool. So we'll start with Docker recap, right? What are Docker containers? This is a very high-level overview. So typically in traditional computing, what used to happen was if you want to deploy an application, let's say if you have a Python application, you buy a server, you deploy a Python application on that server, and you expose it on the internet, right? So it's like a process running on a bare metal VM. But that very soon proved to be inefficient, because what if you want to run multiple applications, right? And if one of them kind of starts hogging a lot of resources, others get impacted. What if that bare metal machine goes down, right? So there were serious challenges in that model. So what the industry came up with was virtualization, right? So in virtualization, what happens is on top of your bare metal, you have a thin layer of hypervisor. And hypervisor is nothing but a piece of software which kind of emulates your infrastructure components. Infrastructure components like CPU, memory, storage, and network, right? So once you're able to isolate that, you also get the capability to install an entire operating system, right? So essentially what happens is you are kind of running an OS just like a process on your bare metal, right? So you can have multiple operating systems or multiple virtual machines running on the same bare metal. This approach, although it's really good and it solved a lot of problems, but what Docker introduced was a leaner virtual machine, if you can say, right? So it removed the dependency of this hypervisor component, and directly on top of your host operating system, you could create this isolated application or containerized applications. And when we say isolation or when we say containerization, what are we isolating here? So typically, Docker uses Linux OS functionalities like C groups and namespaces. We won't go much in depth here, and even if you don't kind of understand this, this is fine. But just remember that C groups and namespaces are OS features that Docker or any containerization platform utilizes to provide isolation. Now, uh, if you have, again, let's take an example. If you have a Python app and you have a machine with, let's say, 4 GB RAM and or maybe let's say 8 GB RAM and 4 cores, and you want to allocate only 1 core and 2 GB to this process, how would you do that? So you can basically use C groups and containerize that application or sandbox that application or put some restrictions on that applications that no matter what happens, it will not be able to consume more than 2 GB of RAM and 1 core CPU, right? Similarly, you can use namespaces to isolate network and storage. And what do you mean by that is, again, let's say if you have that same Python application and you are writing some data to a file, and if that file contains sensitive data, you might not want other processes to be able to read or write contents of that file, right? So you can use you can set that isolation using a storage namespace, right? You can okay, so that's about C groups and namespaces. And about Docker build, push, and run. So we'll just do a quick demo for this. And in the demo, what we'll do is we'll build a sample Docker image. We'll push that Docker image to Docker Hub, and we'll run that Docker image locally, right? So and all this should be like within 30 seconds. So if I go to my terminal, sample app. So in this directory, if you see, there is a sample Python application. It has only 2 routes. One is slash, which kind of returns hello world, and there's a health check route. Okay, and apart from that, there is a Docker file. What this Docker file does is it kind of starts from a base image. The base image here is Python 3.9. There are a ton of options that you can use for a base image. It will set the working directory for that container. It will copy the current directory inside that slash app directory in the container. It will basically deploy all the dependencies, install and deploy the dependencies using pip, and expose 8001. Since our application is listening on port 8001, we are exposing port 8001 here. And finally, you have the CMD option. So where you say Python space main.py, as simple as that. So let's quickly just Docker build hyphen t here stands for tag, and the final argument dot is context, right? So I'm passing the current directory as the context. So if I run Docker build, it should okay. Interesting. Guys, let me just switch my Wi-Fi connection. I think there is some connectivity issue. I'll just be back in a minute. Cool. So Docker build is done. I can verify that using Docker images command. Docker images. Okay. I'll just do a grep. So sample app v1.2 is the image that we have built. To run this image, what we do is Docker run. We expose the port 8001, 8001. We are giving 2 ports because so the first port would be your local machine port, which you'll try to access that service on, and the other port is the actual port where the container is listening. Okay, so fine. So we have this application running, and to verify, I can just work a localhost 8001. Okay, and we have welcome to latest workshop. So this was just a quick summary about Docker. I think we didn't push the Docker image, right? So we'll also see that command. So Docker push. This is how you would push a Docker image to dockerhub, right? Simply. Right. So Docker build, Docker push, Docker run. Any questions so far regarding this Docker thing, container image process, whatever commands that I've run? If you feel lost, I mean, feel free to just raise your hand.
Yeah, in the beginning, like you said, in some context, right? Does context mean that current directory, like where you're running from, or is it something else?
Yeah, so let me just go back to the command, Docker build. So the last argument is context. Okay, yeah. And in Linux, dot means current directory. Okay. So what we can also do is, if I let's say do a cd dot dot, if I come to the parent directory and if I try to run the same command, let's say docker build. In this case, I would not give a dot, but I would give sample app, right? Because my Docker file is inside the sample app directory, right? Since you were inside the directory, we just gave a dot, but you can also give a path to the directory where your Docker file and other contents are.
Okay.
Got it. I think there's a request for that Git URL. Let me just share that. Okay, somebody got it now. Cool. So, any other questions on Docker? If not, I guess we'll just jump into Kubernetes. Cool. Looks like no questions.
Hello. Yeah, Mr. Karim.
Yeah, tell me.
Yeah, I just want to know whether it is best suited for only Unix or Linux environment only. What about Windows environment?
No, I mean, initially it started off as a Linux thing, but I guess people do run containers on Windows as well.
Okay. Is there any special settings that are needed, or are those a part of this today's workshop?
No, in today's workshop, we won't be running things on Windows. I'll be running on Mac OS, but it's again a Unix-based system. So it is focused on Linux and Unix, but it should be
okay. Okay, good.
There is a specific to Unix that I'm using here. Yeah, you can try it out. Okay, so what is Kubernetes? Yeah, Kubernetes is at a high level, as most of us would have already seen, read, and heard multiple times, right? It's a container management system, right? It's a system, it's a set of services, a set of tools, databases that you can use and deploy to manage containers, right? Using Kubernetes, you can deploy and manage containerized applications in a cluster, right? Kubernetes shines when you're talking about a cluster. And what is a cluster? Cluster is a group of nodes, right? So whenever you have more than one VM or more than one bare metal, that is known as a cluster. And an orchestrator like Kubernetes kind of shines when you have this cluster-based setup. If you just have a single VM, maybe Kubernetes would be an overkill for you, right? You could go with something like Docker Compose or even Docker for that matter, right? Or some kind of automation or scripting on top of that. But in clusters, you kind of need Kubernetes. But then again, what does this really mean? This is just more like a definition, right? We need to understand what kind of things Kubernetes can do for us, right? And that's so we'll just quickly go through a list of things that we can ask Kubernetes to do, right? We can offload onto Kubernetes. So first would be, let's say you have a backend service, a sample backend that you want to deploy, and you want to run 5 containers for that sample backend service, right? You can just ask Kubernetes that, hey, this is my image and I need 5 containers. That's it. It will ensure that, at any given point in time, there are minimum 5 pods running for your app. Since this is a backend app, you might not want to expose it to the public, right? You might want to keep it local. And what you can do in that case is ask Kubernetes to set up an internal load balancer, right, in front of these 5 pods. So you just say, okay, fine, Kubernetes, create a service. The type will be load balancer. It will be internal. And these are the 5 containers that you need to load balance between. Similarly, if you have a front end application, you can set up 10 pods, right, for that front end. And since it is a front end, most probably your users will want to use it in their browsers, right, and access it over the internet. So you can say that, fine, Kubernetes, create a service, expose it via load balancer, and make sure that you keep that load balancer public. Okay. Apart from that, let's say if you are running an e-commerce company, for example, Amazon, and there's Big Billion Day coming up, or if you're expecting some traffic spike, right? If you're Hotstar or Geo and there's an IPL or a cricket final match, right? There is going to be unusual traffic on your servers, right? Which will be maybe 10x or 50x or even 100x more than normal. So what can you do in that case? You can configure Kubernetes. You can ask Kubernetes that, okay, fine, I have Big Billion Day on X date. So 3 days before the event, add 50 more nodes, and 3 hours before the event, add 100 more nodes, right? So that as and when traffic starts coming in, we are kind of pre-prepared. And once the event is done, you can gradually kind of also drain those nodes and get back to normal. Another thing would be if you want to deploy a new feature, right? If you want to release a new tag for your front end. So earlier, if let's say you were on 1.3 and if you have built some new features and you have 1.4 ready, you can just say, okay, fine, Kubernetes, in that same deployment, take this image, go and update that image, and it will take care of it. So if you have, let's say, 10 virtual machines and you have 10 containers for this front end, and they are distributed on these 10 virtual machines. Maybe there are 3 pods running on one VM, 2 running on another VM, and 5 running on the third VM, right? So let's say if your workload is distributed between these 3 nodes, and if you were to manually do it using Docker, you would have to manually SSH into every node, figure out which pod or which container is for your front end, kill that container, run the new container, right? And do that for every single node and on every single VM. But in case of Kubernetes, you just ask the control plane, right? You just ask the master that this is what I want to do, and the master gets it done. So it becomes pretty easy. Also, these upgrades, there are multiple strategies that Kubernetes supports. Rolling update is the default one. So what that usually means is, again, if let's say you have 10 pods running for this front end and you introduce a new version, what Kubernetes will do is it will not delete all these pods first and then create 10 pods. It will roll out these changes in batches, right? So it would be, let's say, 3 pods at a time, or 2 pods at a time, or 10% at a time, or 5% at a time. It's fully configurable. And in the demo, we are going to see some examples for this, about this rolling update and recreate strategies. So these are some of the common things that you do with Kubernetes. But it can do a lot more, right? I mean, that's not it. You can do advanced auto scaling. What do you mean by advanced auto scaling? Typically, an auto scaling would mean, or if you have dealt with auto scaling, or if you've created ASGs in Amazon, or even if you have deployed cluster autoscaler in Kubernetes, it kind of monitors your CPU or memory usage, right? And if your CPU is greater than 70% for last 15 minutes, add a new node, right? And if it is less than 70% for last 15 minutes, remove a node. But in real world, that is not sufficient, right? When you have a traffic spike, to have a direct impact of that spike in your CPU usage may not be directly related, right? It may not be directly related. So you might want to kind of auto scale based on some custom metrics, some business metrics. So for example, number of viewers. So if the number of viewers crosses 1,000, add 10 more nodes. that would be an advanced auto scaling, use case. Next is traffic shaping. So if you've done CI/CD, you must have heard these terms blue, green, and canary. Before Kubernetes, it was fairly tedious to kind of get these things done. You had to write a lot of blue code in your CI/CD pipelines to achieve zero downtime, blue, greens, and canaries, right? But with Kubernetes, it's pretty straightforward. Not just with Kubernetes, there are a lot of plugins as well that are built on top of this Kubernetes ecosystem, right? So Argo rollouts is one such tool which kind of makes this really easy, right? You just go and define that for this particular service, I need a blue-green deployment strategy, and for this particular service, I need a canary strategy, right? Then you can also run your batch jobs, right? Cron jobs. Any software company that you will see a ton of cron jobs running, right? And nobody cares about them until they fail. But yeah, you'll find them everywhere. So you can also kind of run batch jobs or cron jobs on your Kubernetes. Another advanced use case would be to set priorities. So even if you, let's say, have a cluster and you have auto scaling and your nodes are coming in, and there's going to be a ceiling to that auto scaling as well, right? There's going to be a point where you hit a limit, and in that case, if you have some services which are low priority, or rather, if you have some services which are high priority, you can define that. So Kubernetes will ensure that these services are always running, and if in case there is a capacity crunch, a particular set of services should never be evicted, right? And if, let's say, it's a low priority service, it can be evicted, right? It can run in a degraded mode, right, rather than being completely down. You can also run stateful sets, right? Stateful sets is a Kubernetes specific term, but any service that kind of depends on data persistence is a stateful service, right? The most common example is a database. MySQL is a process, and that process kind of writes your data onto a file somewhere on the VM, right? And that process is dependent on that file, on that data file. If you lose that data file, your process in itself is not really that useful. So you need to always couple. So in case of a stateful set in Kubernetes, you can couple a pod with a volume, right? And these two things together, they always travel together, right? If it gets killed on one VM and goes to another VM, the volume follows that pod, right? So you can do that. And then you have fine-grained access control. Yeah, this is really important from security point of view. Since now Kubernetes will allow you to create clusters, and by clusters, what you typically do is run a lot of components, onto it rather than running a single component. And your teams would want access to kind of interact with these components. So to make sure that one team does not step another, your dev team does not kind of go deploy something in QA or the other way around. You would need to set some boundaries, and you can use RBACs in Kubernetes to kind of set those boundaries. Not just that, let's say if you have multiple environments running in a cluster, you would not want a service running in dev environment to be able to talk to the database running in QA environment, right? There should be an isolation there. So you can also kind of isolate things there using access control and policies. Finally, there are operators. I won't go much into depth here, but operators are kind of, you can think of it as a piece of code which mimics an ops guy, right, in your company. So your ops guy would kind of do some complex stuff. So again, if you take an example of MySQL, and you are running MySQL in a replica mode, so you have one master and you have multiple replicas. Tomorrow, if you get a requirement to create a new replica, right, you can't just create a VM and consider it to be done, right? There's a series of steps that operator or the DBA would have to do, right? Maybe let's say take backup of the existing data, rsync that data into the VM, attach the VM or register the replica with the master, start the replication, and set some monitoring, right? So all these complex set of instructions you can codify and run as an operator inside your cluster, right? But these are all advanced level operations here. Cool. So now next what we are going to do is we are going to do a rapid Kubernetes demo. I just just run a deployment. I'll expose that deployment and on some of the activities that we discussed here, right? The scale up, scale down. I'll just scale up pod. I'll try to access that pod, and we'll just roughly see how it works, and then we'll go in detail into some of these components, right? Like pods and deployments. So we'll just do a rapid demo here. For that, yeah. Okay. So the first thing is we create a pod, a deployment using echo server image. This is an open source application which just echoes back metadata of the pods that you're running this image on, right? A pod or a VM, whatever, wherever you are running it. So we'll just quickly, before that, let me, okay, nice. Okay, so kubectl create deployment. If you just try to understand this command, it will create a deployment. The number of replicas will be 3, and the image name is elang/echo server. And what I'll do is on the right side, in my terminal here, on the right side, what you see is this is a user interface for Kubernetes for my local cluster. I can also use kubectl and we'll also use that, but this will continuously keep on monitoring, my cluster. So as soon as I run this command here, kubectl create deployment, what you'll see is you'll see 3 pods that have come up, right, immediately. So although I've created a deployment here, I can see that there are pods being created. If I run kubectl command as well, if I run kubectl get pods, I can see 3 pods. These are the same pods, right? But this tool called K9s, it allows us to kind of monitor things, right? So this is good for demo purpose. So my deployment is created. After I've created my deployment, I would want to access that service, right? Because this is a public service that I want to deploy. So I'll just run kubectl expose deployment. And I then give the name of the service. So in this case, I'll just call it echo server. The type that I've mentioned here is load balancer. We kind of discussed the service types probably in the last section, but for now, just assume that a load balancer service type is something which allows you to expose your service to be accessible from outside the cluster, right? By default, it would be cluster IP, but since I'm specifically mentioning load balancer here, I want to access it from outside the cluster. So once we deploy and expose this, I'll be able to access the service from my local machine. Okay, so this is done. What I also need to run here is minikube tunnel. Now, this is a hacky way to set up a load balancer. And again, we'll discuss this in detail in the service section, in the load balancer part. But for now, just understand that if you want to run service type load balancer on your minikube, you need to run minikube tunnel command, right? And it's you have to keep it running. If you kill this, your tunnel is broken. So I run this in a new terminal. So that's it. I create a deployment. I expose the deployment, right? And the service is accessible. So if I just run localhost, awesome. So it's responding. What I can rather do is I can run curl localhost and I can echo the pod name, right? Right. So if you see here, the response that I'm getting is echo server. Then there is some random number, and then there is a random string. But this matches with one of the pods that have been deployed, right? So if you see the last pod here, SNWJ6, it is matching. What happens if I run this command again? This changes, right? Randomly it would change. So now in this request, I got response back from 5SS, which is this pod, right? So if I keep on running this, I'll keep getting responses from different pods every time. Which means Kubernetes service type load balancer is actually load balancing between 3 pods. If I have 10 pods, it will cycle between 10 pods, right? If I have 100, it will cycle between 100. That's the default behavior. What happens if I kill one of these pods? So out of these 3 pods, let's say if I just one of the pod dies. So if you see on the left side, I'm running this in a loop. I didn't really have an impact here. And if you see the pod, although it died, it came back again. So looking at the age, you can see that there are 2 pods that are running for 3 minutes. And there is one pod which died and it immediately came back, right, in 22 seconds, 22 seconds ago. How did this happen? This was taken care of by deployment. And again, we'll see that later. One more part in the quick demo is scaling up, right? So if let's say, currently I deployed it with 3 replicas. If I want to run 10 replicas, right? So if I just run this command and you see that Kubernetes will take care that there are 10 pods of this particular deployment running, right? What else? Okay, update image is also there. Now we started with one image. The image was echo server, right? What if you want to deploy some other image here, right? Now, ideally, you would not want to do that. Ideally, if you start with echo server, you would maybe change the version of echo server, right? But for the sake of example and just to show that it is possible, what I'll do is I'll replace the image of this deployment, right? From echo server to nginx, and we'll see how the response changes. So before we do that, let's just once again run a curl, right? So this is the response that I get from echo server. Now what happens if I change the image? Okay. So as you can see here, new containers are being created here. And if I go inside the container, I see that the image is nginx. Okay. And this will be visible also from the curl response. So if I run curl localhost, now you see that the response has changed. I'm getting a welcome to nginx page here, right? And never do this in production. This is something that Kubernetes allows you to do, but does not mean that you have to do. And you have to be careful about this, that your image, only the version is something that you should be changing and not the actual image itself. But if required, you can go ahead. So fine, this is a quick demo. We just clean up whatever stuff that we've created here and we move on to the next stuff. By the way, this way of doing things, creating deployments or exposing services or setting image, using individual commands here, right? This is known as imperative way of doing things. Whereas creating manifests and applying those manifests to your control plane and letting the control plane kind of ensure that the actual state of the cluster and the desired state is matching. That is known as the declarative way, and that is a recommended way to do things. But typically in a job, you should be comfortable with both the ways of doing things, right? Because this imperative way is usually quicker, it's faster in case of debugging, right? It's really handy. But once you're done with your testing, once you're done with your debugging, it's always recommended to kind of push things in a manifest, push it to a Git repository, and kind of make sure that everything kind of is in sync with your Git, right? Yeah. So that was a quick demo about a rapid demo on Kubernetes. Next, we'll just quickly go through some of the kubectl related concepts, right? So for example, where is the kubectl configuration stored by default, right? What exactly a kubectl config file looks like. Okay. We'll also see the context. So there's a thing called context in your kubectl. So we'll also see that. And we'll probably see a bunch of commands like kubectl explain and kubectl exec. Point number 4 here, this one, kubectl explain. This is really important and really helpful because it exposes the entire documentation to you on your command line immediately, right? So we'll maybe start with that. So since we are dealing with a deployment here, what I'll do is I'll just maximize this here. Okay. Is the font size good enough or?
interesting.
Good.
Yeah. So you're running the cluster using, nodes using the Minikube right here. I think your voice is.
Yes, I'm running it using Minikube.
So something that is called as Kubernetes kind. So is that same? Like I really don't know the difference between the Kubernetes kind and the
I mean, it won't be correct to say that it is same, but I would say that Minikube supports Docker driver. So let me show that. So if I do Minikube profile list. So if you see the VM driver here, right? VM driver column. So I have two clusters running, and the driver is Docker. And if I'm not wrong, this kind of utilizes kind behind the scenes, right? And you can have multiple. You have multiple VM drivers, supported in Minikube. So you can have VirtualBox, you can have the OSX default. I forget the name as a VM driver. So in that case, what happens is it creates a virtual machine, and inside that virtual machine, your entire Kubernetes stack is brought up. But using this Docker driver, the entire Kubernetes control plane, data plane, all of it is running inside containers, right? So it's like Docker inside Docker kind of thing. But again, I mean, I've never seen it being used in production. It's more for this development kind of use cases. The one that I'm doing right now. Okay, does that answer your question?
Yeah.
Okay. So we'll start with kubectl explain command. So if you do kubectl explain, you see that it gives the entire documentation, right? Even if you go to the website and check, this is the same stuff that you'll be seeing there, right? So you can see what a pod is. You can see what all fields are available in a pod, right? And you can also dig deeper into it. So if I want to see more information about, let's say, API version in pod, or let's say if I want to see more information about the spec section in pods, I can do pod.spec, right? And it gives me all the possible options that can be configured in pod.spec, right? And details and description about it. And it also points to official docs if required, if you want to read more, right? And yeah, so this is a really helpful command. If you're new to Kubernetes, make sure that you kind of use this. So you can run this on any Kubernetes object, right? So you can run this on service. You can run this on secrets, whatever objects are available. kubectl explain is your friend. It should be your first, go-to thing to kind of understand whenever you're blocked. Next would be kubeconfig file. So what is a kubeconfig file? Let's just quickly open my current kubeconfig. So kubeconfig by default will be in my home directory. Inside my home directory, there is a directory called kube.kube, right? This is where my kubeconfig file will be. So home directory, .kube, and then config. This is the full path name. So if I open this, right? So as you can see, there are. Let me just minimize this first. Cool. So there's a cluster section, there is a context section, and there's a user section, right? These are the three important sections here. So let's start with clusters. I can see that inside clusters, I have two clusters defined here. So first one is KTS 1.20, and second cluster is KTS 1.23. So if you remember, when I ran Minikube profile list, I can see that there are two clusters that are provisioned using Kubernetes, and that's why you can see two different sections in my kubeconfig file. I can also get that information using kubectl get get clusters, right? So if I do kubectl config get clusters, what this command does is it parses your kubeconfig and shows you the available clusters in your config file. Apart from clusters, you will see the context section. Now, what does that context mean? So context here would kind of define, let's say, what is the default namespace that you want for your kubectl to follow. So when I run kubectl get pods, I'm not specifying any particular namespace. Namespace is basically logical separation of resources inside your cluster, right? So if I run a pod, so we ran echo server. So we can run echo server for dev team. We can run echo server for QA team, and we can also run echo server in prod. And all these three can run in the same cluster, right? Theoretically. So namespaces is one of the ways that you can isolate these three, deployments and ensure that one does not talk to the other. So in context, you'll find information about the default namespace, right? And in this case, the name of the default namespace is also default, but you can create, let's say, a dev namespace and have that as your default namespace here, right? In context. And last is users. So since we are using Minikube, it uses certificate-based authentication. So this is where it kind of creates your identity or secret files and uses this to authenticate with your server, right? Your Kube API server. This is your server address. So this is about kubeconfig. Explain kubeconfig file. Okay, we'll also see some examples of kubeconfig. So let's say if I run kubeconfig, kubectl get pods. Okay, I can see that there are no pods running here. Kubectl create deployment. I just create the deployment again. And if you run kubectl get pods, you can see that I see 3 pods. But in the same command, if let's say I give context, before that kubectl config get context, right? There are 2 contexts available for me. Now if I run the same command kubectl get pods --icon context, and if I give a different context here, right? Not the default one. So the one marked with star is your default context. I give it a different context. It says no pods in default namespace, right? Let's do it once again. So kubectl get pods. I can see 3 pods. If I change context, it says no pods. Clear? Because I have multiple clusters and multiple contexts defined in my kubeconfig. What you can also do is you can pass your kubeconfig as an argument to kubectl. So if you're dealing with tons of clusters, right? If you have 15, 20, 50, 100 clusters, it's not really convenient to switch between contexts and manage everything in a single file. In that case, what you would want is maybe create separate config files for every cluster. So if I, let's say, move my kubeconfig file to a different location, if I move it to kubeconfig new, okay. Now my kubectl command by default will fail because there is nothing in the default config location, and that's where kubectl is looking for. But what I can do is I can pass kubeconfig as an argument, and I can give it the path to my configuration file, right? So now this starts working. Clear till now? Any doubts? Any queries? Any questions? No. Awesome. Let me just replace the file. Cool. So the final thing that we'll see with kubectl is kubectl exec. Kubectl get pods. So what if you want to get inside a container and do some debugging, right? So similar to how you would SSL into a VM and maybe take logs or check the process or do whatever you want to do, right? Do some debugging stuff there. You can exec into a pod using kubectl exec command. So what is the syntax for that? The syntax would be kubectl exec and you would give the pod name. What you also need to pass is -it for interactive. Then you give the pod name, and after that you give the command that you want to execute, right? So since I've given sh, I got the shell here, right? So now I'm inside the echo server pod, right? This is the echo server application. If you don't want it to be interactive, you just want to run a particular command and get the output. Let's say if you just want to run ls, right? You can do that as well. So in this case, you see that I don't get the control. I just get the output, right? So it depends on you. If you want to SSH or kind of connect inside the container, you give -it command. And if you just want the output, you don't give the -it command. Okay. Cool. So that's about kubectl. Now let's jump into Kubernetes architecture. So this is a simplified version of Kubernetes architecture, and I think it's too simple for us. So and this is a joke, right? Because I don't understand most of the stuff that is mentioned here. I just found while I was trying to search for Kubernetes architectures, this was probably one of the first images that came up, and I thought, let's put it here. But if anybody is interested, you guys can study this. For the rest of us, I have a simplified architecture here, right? So on a high level, you see that it's divided into two sections. The first one is the control section. It is also known as the control plane, or some people also call it master plane or master or whatever. But nowadays, it's most popularly known as control plane. And the second section here is the node section, or it is also known as data plane, right? So in the control plane, you see that there are a bunch of components. The most important component here is Kube API server and HCD. So HCD is the database of your cluster, of your control plane, right? It is a key value data store, but don't go into the key value part. Just think of it as a database, right? Think of it as Redis, if you've used Redis, or even MySQL for that matter, right? It's a persistent key value data store. And then there's a controller manager. This controller manager basically is not just one component. There are a bunch of controllers, and you can also deploy more controllers, for your cluster. But by default, there is a controller manager, and there's a scheduler. So the scheduler, we'll go through what each of these components does in short in the next slide, right? So these 3-4 components kind of come together and they form the control plane, right? And anybody that wants to give any instructions to the cluster or fetch any data from the cluster will have to talk to Kube API server, right? So if you look at the arrows, if you follow the arrows here, whenever I was running kubectl command, what I was doing was I was talking to Kube API server, via kubectl, and also the worker nodes. Whenever they do anything or they are requested to do anything, it comes via Kube API server. Nobody directly talks to HCD or any other component. It's all via Kube API server. So it's really important that this Kube API server is always up and running. And although you see that there is one box here for control plane, but it can be slightly misleading, right? Even these components are horizontally scalable. So in a typical production environment, you would see that there are multiple instances of Kube API server running. There are multiple instances of controller manager. There is a cluster of XCD, right? So for simplicity, we've just shown it as one blob. And coming to nodes, right? This is your user space. This is where my Echo server pod was running, right? The pods that you see here, this is where my Echo server was running. It was running using a Docker container. And who was creating the Docker container? Kubelet was creating the Docker container. Who asked Kubelet to create the Docker container? Kube API server instructed Kubelet to create the Docker container. And when I expose that service, there's a component missing in this diagram. It's called as kube proxy, right? Kube proxy is responsible for setting up the networking required for pods to communicate with each other and also to the outside world, right? So as we had briefly discussed, that if you have everything running on a single machine, single bare metal, you don't need an orchestrator like Kubernetes, right? Because everything is kind of local. But if you have, let's say, a cluster of nodes, if you have 10 nodes, 100 nodes, 500 nodes, and if you have 3 pods running on node 1 and 2 pods running on node 55, right? They should be able to talk to each other. If node 55 crashes and there's a new node that comes in place of that node, right? There should be surety and there should be guarantee that the connectivity that was there is going to be there even when the new node comes in. If a node goes out, all the pods which are remaining should still be able to talk to each other. So Kube proxy, Kubelet, Kube API server, all of these tools kind of come together and provide there's also CNI, CSI, and CRI kind of stuff, right? So container storage interface, container runtime interface, and container, I would say, network interface, CNI, right? These are kind of plugins which kind of help, and all of these kind of come together and provide you these functionalities. So for us, it's a simple kubectl command, but behind the scenes, there's a lot of magic which is happening. So yeah, I mean, let's just quickly go through the roles and responsibilities of these components. So Kube API server, it exposes all the Kubernetes functionalities over an API, right? So whatever you want to get done from a cluster, you go to Kube API server, and when I say you go to that cluster or Kube API server, what I mean is you make an API call, right? It can be via curl, it can be via your programming language, or it can be via kubectl, right? But it has to go to Kube API server. HCD is the database of your cluster, right? It stores one of the important thing that it stores is the desired state of objects, right? And what is the desired state? We'll look at this desired state thing with an example later when we talk about pods and when we talk about deployments. But keep in mind that a Kubernetes cluster will always try to ensure that the actual state of the cluster is in sync with the desired state, right? The desired state is what you ask that cluster to do, right? And the actual state is what is actually running there, right? So for example, if you want 3 pods of Echo server to be running, right? That is your desired state that you have desired, right? And you've asked Kubernetes to do it for you. But when Kubernetes goes and tries to run those 3 pods on your worker nodes, only 2 of them come up, right? There is no capacity to run 3. It is going to raise an error, right? Or it is going to add a new node, right? If you have cluster autoscaler enabled, it will do whatever it is capable of doing to ensure that your desired state is matching your actual state, right? So the data about desired and actual state is actually stored in your HCD. It also stores other important stuff like it would store your config maps, it will store your secrets, and anything that needs to be persisted goes to HCD, and HCD stores it. So it is really important that if you're running your control plane, let's say if you're not using a managed service, right? And if you're running your own control plane, you need to have really solid backup and restore plans for your HCD cluster, right? And also make sure that you don't use this HCD for anything else other than Kubernetes, right? People kind of do that, and it doesn't really go well. So coming to Kube scheduler, again, it's fairly straightforward as the name suggests, right? It will decide which pod goes where. So if the cluster gets a request that I need to add 1 more pod to this deployment, and if I have 5 different VMs, where should this pod go, or on which node this pod should be deployed? Kube scheduler is the component that decides that, right? And it kind of passes this information to, let's say, API server, and API server will pass it on to your kubelet, and kubelet will create the pod, right? So that's simply put, that is the role of your Kube scheduler. Controller manager. The controller manager is nothing but, you can think of it as a loop, right? It is a while loop, infinite loop, and the responsibility of that loop is what we discussed in HCD, right? To ensure that the current state matches the desired state, right? Where does it get the desired state from? It gets the desired state from HCD. And where does it get the current state from? From the cluster itself, right? So it will always kind of run this in a loop, and if it finds a diff, it will make sure that the diff is eliminated, right? If a pod is missing, it will create a pod. If there is no capacity, and if you need to create a VM, it will ensure that a new VM is created attached to the cluster and the pod is created, right? So it will try its best to kind of make sure that these 2 states are matched. There's one more component which is optional. Again, it was not in the diagram, but which is also known as Cloud Controller Manager, right? Fairly new stuff, but if you think of an example where you are running your cluster in Amazon, you deploy a pod, or you create a deployment, you want to expose that deployment using a load balancer. So if you remember, we gave type load balancer, the rapid demo, right? So if you're running EKS, by default, the behavior would be if whenever you create a service with type load balancer, a new ELB is created for you, right? An actual ELB is created in your account. Your nodes are kind of attached to that ELB, and the service that you define, right? The selectors, using the selectors, the pods are kind of attached to, the traffic goes to the pods that you define, right? So for every service of type load balancer, a new ELB is created. And how does that happen? That happens via Cloud Controller Manager. Some more information about control plane. If you are running your own control plane, then it's a good practice to run it on dedicated nodes, because in a cluster, there's not much difference between a control plane and a data plane, right? In itself, you can actually run your applications on control plane itself. And if you see that in Minikube, I just have one node, right? I don't have a different node for my control plane, a different node for my data plane, right? It's just one VM, and everything gets deployed there, right? So API server, HCD, controller managers, my applications, everything goes to a single node. But if you're running production, you should kind of dedicate a set of nodes for your components that are in control plane, and keep it separate from the data plane. In case of managed services like EKS, you usually would not even have access to your control plane except for your Kube API, right? So you would not be able to see your Kube API server or your controller manager or your HCD, or even access it, or see how many pods or instances are running, what CPU it is using, nothing. All you get is an endpoint, and you can just use that endpoint, and AWS takes care of kind of ensuring total uptime. It also takes care of upgrading the control plane, right? But that's not the case if you're managing it on your own. So moving to the data plane. Data plane has container runtime, obviously, because it is a container orchestration platform, and it needs to run container. But you need not necessarily have to deploy Docker, because there are other container runtimes which Kubernetes supports. For example, Containerd or Cryo. And honestly, this is an implementation detail, shouldn't really matter much, but it's a gotcha, right? And good to know that Docker and Kubernetes are not directly related. Kubernetes is a container orchestration platform, not a Docker orchestration platform, right? Kubelet. So Kubelet, it gets the instruction from Kube API server and makes sure that the container is up and running on the node. So your kubelet should be aware of what container runtime is deployed, and if these things are configured properly, it can follow the instructions and create containers. Kube proxy, as we discussed, it manages network between pods, but with a star. Kube proxy in itself is not sufficient. So as we discussed, there's something called a CNI as well, right? Container networking interface, which kind of they work together and kind of give you end-to-end networking functionality in a cluster. Nodes are, by the way, called minions in early days. So if you're reading some old documentation, or if you come across some old video, you might hear the word minions. So what they mean by minions is a worker node, or a node running in a data plane. Okay. So any questions so far?
Yeah, Abdul, for etcd, can we access it directly, or like every time we have to access this through API server?
Say that again.
It's about etcd. Okay, that's your database of clustered. So like every time we have to access etcd from API server, or we can directly access it if you want to anything troubleshoot or config apps and all.
Okay, so there are two parts to the question. First is, if you are running a managed Kubernetes cluster, you don't even have access to etcd directly, right? Only way you can access it is, let's say, fetch data using kubectl or make some API calls. But if you're running your own control plane, so if you create 3 VMs and deploy all these components there, right, your etcd, your API server and everything, then it's totally up to you, right? And people can do that. People use tools like KOPS or kubeadm I think kubeflow, and they said they allow you to kind of run your own control plane. In that case, it's totally up to you. If you choose to expose etcd to be accessed outside of the cluster, you can do that. There should be nothing that stops you. See, it's nothing. etcd is just like it's a key value store, right? And it's like Redis. So if you use Redis, right, you can access Redis whenever you want, right? Your applications can access it, you can access it. There is a CLI, there's an interface. You can do the same thing with etcd as well.
Means for managed Kubernetes services, I can't access it.
No, you cannot. It's very critical, right? I mean, if it goes down, your cluster is down. I mean, of course, your data plane will continue working, but your cluster activities will go for a toss. So it's very critical. I have not seen any managed any managed Kubernetes provider kind of exposing etcd.
Okay.
Abdul, like in the beginning, you said like Kubernetes can be used for running this batch cron jobs, right? Can you explain like how would that work? Like I have a set of cron jobs which I run on a server. If I have to do that
Right.
with Kubernetes, like how would it be?
You would create a YAML. The kind would be job instead of a deployment. And just like you set up cron jobs, right? You give a schedule. You would give a schedule there that I want to run, this job at this frequency, and the orchestrator will take care of it. But the only difference is it kind of runs inside a container, right? Versus a typical cron job is a process, right? You can also run Docker containers as cron jobs, but here in Kubernetes, everything is a container. So think of it as a pod that comes up every 5 minutes and does its job and kind of dies. And then after 5 minutes, a new pod comes up. So if you want, I can share a sample YAML. It's not covered in this workshop, but probably at the end of the session, I'll just we just quickly pair up and Google a sample YAML for you.
Okay, sure. Thanks.
Yeah.
Mr. Karim.
Yeah.
Yeah. Are there any monitoring tools like within this one control plane to see the pods functionality, whether they are working fine or not? Like.
Yeah, tons of monitoring tools. There are tons and tons of monitoring tools. So starting with managed monitoring tools, you might have heard of tools like Datadog, New Relic. All of these kind of support Kubernetes, out of the box. It's fairly straightforward to integrate these tools with your cluster. And if you talk about open source, then Prometheus is the most popular one. And also a tool that is used. So Prometheus, along with Grafana, is a solution that a lot of companies use, right, to monitor your cluster. So, like you said, if you want to monitor the status of your pods, so if one of the pods is kind of suddenly not healthy or not coming up for whatever reason, it is stuck in a state where it is not able to get ready, and you want an alert based on that, you can do that. Right. You can also set some advanced rules, right? So if you have 1,000 pods, and if just one pod of that application, right? If you have 1,000 pods for a single application, and if just one pod is stuck, and 999 are kind of running fine, you might not want an alert, at 3 a.m. in the morning for this particular use case. So what people usually do is you can set percentage-based rules. So you can say that if 10% of my pods, for this application are stuck for whatever reason, then send me a page or send me an alert. So you can do a lot of stuff using Prometheus, Grafana, and Alert Manager out of the box.
Okay. Thank you.
Okay, so I have one question for you. So in this case, let's say my Kube API server crashes, right? I have a cluster which is up and running, which is running for 3 months. I have 100, 200 different applications running on my cluster, right? Things are fine. And one fine day, this Kube API server crashes. What happens to my applications, right? What will be the impact?
I don't think anything should happen to their applications. So the API server is one of those layers that acts as a communication between you and, like it's like a translator. between you and the actual thing that Kubernetes does. So even if the API server goes down for a certain period of time, your application should be up and running along that time.
Okay, that's correct. That's correct. And that was the answer that I was expecting. So there is a clear isolation between control plane and your data plane, right? And that's why people kind of don't deploy your user applications in user, and they keep it separate. So if your Kube API server or any of your control plane component crashes, the running containers in your data plane will not be affected. But what will be affected is, let's say, in the rapid demo, I showed you that there were 3 pods. I killed one pod, and there was another pod which came up in its place, right? Immediately, because there was a deployment which kind of was making sure that there are 3 pods running. That functionality will not be there. So if you're eventually over time, if you don't fix your control plane, things will kind of, issues will kind of seep in into your data plane as well. But immediately there will be no effect as such, right? Yeah, so I think Ashish Kumar has shared the web UI dashboard. Yeah, I mean that's a good tool. It's, I guess, official Kubernetes dashboard. That is also something that you can use. It's more like a dashboard to your cluster rather than detailed monitoring. But yeah, thumbs up. Cool. So any other questions about this architecture? Fine. I guess we can move ahead. This pods. Cool. So let's start with pods. What is a pod? Pod is nothing but a group of one or more containers. Ideally, you will see pods with a single container most of the time, but and that is a recommended way. But you'll see there are some patterns like sidecar patterns where people kind of run a group of pods together, right, inside a group of containers together inside one pod. But typically, a group of one or more containers is known as a pod, and it is the smallest deployable unit of computing in Kubernetes. What do you mean by that? What I mean by that is using kubectl or using these Kubernetes APIs. I cannot directly go and create a container on my worker nodes. It is just not possible. What I can do is I can create a pod, right? Below pod, I just cannot go, right? Pod is the smallest deployable unit here. And a pod can have multiple containers. So if when we check pod.yaml, we'll see that there's a container section in the pod.yaml, and you can define more than one containers in a pod. So pod is a group of one or more containers, and it is the smallest deployable unit, right? All containers in a pod, they share the same network and storage namespace, right? So now recall the namespace part that we discussed earlier, right? So network and storage namespace. Typically, what this would mean is all the containers running inside a pod will share the same IP address and will share the same storage. So if container 1 is writing to a file in a pod, container 2 will be able to access. Let me just try to draw this out to explain this better. Right. So if let's say this is our pod, this big box is my pod, and if let's say I have 2 containers running in it, C1 and C2. Okay. Now this pod will have an IP address 172.168.0.1, right? So this pod will have a common IP address, which means both these containers will share the same IP address. Also, if I write to some file here, right? If I let's say write to a local file, both these containers will have access to this file, right? They will be able to read and write the file. But now if you take another pod, right? This is another pod, and the IP address here is 172.168.0.2, right? will not be able to access this file. Right? So containers within the same pod, they can access these files. Containers, running in different pods, they cannot. By default, they cannot. There are ways you might be able to get it done using some shared file system or whatever. But as an architecture, this kind of isolation is something that a pod provides. Now you may ask that if it is not recommended to run more than one containers in a pod, why do people do it? Right. So there are very specific use cases for which people do it. So for example, logging is a very common use case. So in this case, instead of C1, C2, let's call it my Python app, right? It's writing to a log file, right? It is writing log file, and I need to run an agent, right? So a typical log collector would be logstash, right? I need to run logstash to basically consume this file and write it to a third party, whatever, Elasticsearch, right? I have an Elasticsearch cluster, and this is what I want to do. So in that case, what you can do is, along with your Python application, you can just ship a lightweight container, right? Typically, these sidecar containers are not very heavy. They are a single purpose, containers, and they kind of complement your actual application container here, right? They are not independent blocks. So what I mean by that is a setup like, let me just copy this. So instead of this, if I take PHP and MySQL, right? So PHP directly would not write to a file here, actual data to a file. What it will do is it will talk to maybe your MySQL, and MySQL will write to a file, right? That's how a PHP application would be, right? If you think of a WordPress setup. Now running these two pods together, these two containers together inside a pod, this is not recommended, right? This is considered to be wrong. Any guesses why this would be wrong? Why this is correct and why this is not correct? Or rather, why the first option is recommended and why the second option is not recommended? No guesses?
I think the pod restart means both will restart. Even the database also restart, which doesn't need actually to restart of the database itself also.
Right. That is a good point. That is one of the reasons.
And if we kill any one of the node, it might kill other nodes inside that which is dependent. So it's not
good point. If this pod, if I just have one pod of this package, running, and if the node dies, it's totally gone. Everything is gone. Good point. Anything else? What if I want to scale up this application? What if I'm getting more traffic? Will I create 10 PHPs and 10 MySQLs? Will that be a good enough solution? And if I even create, let's say, 10 pods, right? Or forget about 10 pods, even if I just replicate this, if I have 1 + 1, right? Okay, even if I just replicate this, now what happens to the data which gets written here and what happens to the data which gets written here, right? They're two different pods. How will you synchronize these two databases, right? It won't really work out of the box. So this is an example where it gets really clear, right? If you want to scale up individual components, it becomes really tricky, right? Even if it's not a stateful set, even if it would not depend on a database, right? And if you had some other component here, right? So let's say PHP and some Ruby application. If you just want to scale up PHP, why would you package it with Ruby and also kind of give resources to that Ruby application, right? You want your independent application to be scalable, upwards or downwards, right? I should be able to multiply the number of PHP containers independently of any other service running in my cluster. So to kind of maintain that isolation, it's kind of not recommended to have independent components running together inside the same pod, right? So PHP is independent. and this MySQL plus database is in a way an independent component. So it doesn't make sense to club it together. But in this case, in this logging case, I mean, logstash is kind of, I mean, standalone, it means nothing. If it does not have any logs, what is it going to kind of tail, and what it is going to push to ES? Nothing, right? Because it's a very, very lightweight, container which kind of just piggybacks on top of your application. So logstash is just one example. Service mesh is another example. So if you've heard of, or if you've worked with service meshes like Istio, you would see that it injects a sidecar, with every deployment that you have. So yeah, that's about pods. Okay, this is just an image that kind of describes the pod package really well, right? So let's start from the rightmost section here, right? Here we see that we have a pod with 2 volumes and 3 containers, right? So these green cubes are containers, and these cylinders are kind of your volumes, right, where the data is stored. So all of this kind of is inside the same network namespace, right? So all 3 containers have the same IP address, right? And all 3 containers can access both these data volumes. And you can kind of eventually, break it down to, let's say, 2 container, 1 volume, 1 container, 1 volume, and just 1 container, right? So this would be a stateless application. A typical stateless application would look something like this. This would be a stateful application, a typical stateful application, right? Pod 3 is an example of I would say, a stateful application with a sidecar, right? A small container running as a sidecar. And pod 4 is just chaos. So never do pod 4. That's an example. Cool. So now next we'll just look at a YAML example of a pod. Okay. So this on the right side, this is your YAML file. This file is pushed in the resource Git repository that has been shared with you. So if you have it, maybe you can just go through it. So yeah, I mean, this is a very simple pod example. We start with API version. API version is typically V1. We'll not go into depth of what exactly that means, but on a high level, your Kubernetes versions keep on changing, and the definition of resources, right? So by resources, what I mean is the kind here, right? So kind pod. So this is a pod resource, right? So that is a terminology that is used. So based on the Kubernetes version, your resource kind of definitions keep on changing. Your arguments might change. The default expectations of the arguments might change. So all the resource definitions are tagged to a version, right? So that you can ensure forward and backward compatibility. So API version is V1. Your kind is pod because you're creating a pod. Then there is a metadata section. In metadata, first thing is name, right? So anything that you create, any resource that you create, if you create a file, if you create a folder, if you create a directory, database, anything, image, you give it a name, right? So this is that name. And in every resource, you'll find a metadata name section. Next is the label section. This is an optional section. You may or may not use it in case of pods or any resource, but we'll see later why this is important. This is important because it is used by, it is basically used for grouping purposes for higher level resources like replica sets or services, right? So for example, in the rapid demo, when I said I need 3 pods, right? I need 3 replicas of this particular image, right? Create a deployment with 3 pods. So it kind of groups together everything using labels. Since that was that was an imperative way of doing things, so there was a bunch of magic that happened. But here, when you're writing YAMLs, you have to kind of be slightly more verbose about what you want to do, right? So here we are creating a pod named Nginx. We'll add a label app:(Nginx) to this pod, and then in the spec section, we give the details about the image, the ports, the resources, and all that are required for the pod, right? So here we see that the container name is image, the container image, and the port that the container is listening, right? So this spec section, this goes to your etcd, right? So now if you recall that there's a reconciliation process which happens, right? There is a reconciliation process which is done by your controller manager to ensure that the desired state matches the actual state. So this YAML which you submit, this is your desired state, right? This is the spec that goes into etcd. This YAML file means nothing in itself, because when you apply something, it goes to etcd and that's where it is stored, right? That is your actual desired state. Your local YAML file is not your desired state. Your desired state sits in your cluster. Okay. This YAML file, local YAML file, is just a means to update your etcd. Okay. Next comes deployment. So first we saw pods. After pods, we'll see deployments. So what is a deployment? This is a really fun image that I found. Just trying to look for stuff that kind of describes what a deployment, what a relation between a deployment and a pod is, right? So deployment creates a replica set, right? It may create one or more replica sets. Again, we'll see some demo around this. So deployment will create replica set. A replica set creates pods, and inside pods you can have containers, right? So and again, if you see, one pod can have more than one container, right? So a father can have more than one children, but a particular container cannot have more than one pod. So the other way is not possible, but when you come from top to bottom, a deployment can have more than one replica set associated with it, right? So the deployment is a parent of replica set, and a replica set is a parent of a pod. So yeah, I mean, a deployment replica set pod, the image kind of explained the first point here. What a deployment object also provides is some advanced strategies, right? Advanced strategies like rolling updates and recreates. So again, we kind of touched this point very briefly in the beginning. So let's say if you have 10 pods running, and if you want to introduce a new version, a new image, right, for your backend service or your front end service or any service, what is the method of rollout that you want to go ahead with, right? Do you want to do it in a single shot, or do you want to do it step by step, right? So default is rolling update. Again, we'll see the demo of this rolling update and recreate strategies and see how it actually impacts your users. And it's not recommended to use replica sets directly anymore. So I think deployment is the latest offering that Kubernetes as a service kind of provides, or as a platform provides you. So directly creating pods is not recommended. Directly creating replica sets is also not recommended unless you're doing it for some debugging purpose. You should always create a deployment, kind deployment, right? So if you see kind deployment, you should always create deployment objects. Again, there's metadata, there is name, and there is label. So see that this is a very common theme across all the objects that you'll be creating. So inside deployments, the spec section, here you define the number of replicas. So number of replicas that we want here is 3. If you kind of now check with the rapid demo, you'll see that there are patterns. So this was the imperative way, right? You just went ahead and said kubectl create, right? And create a deployment. How many pods do you want? You want 3 pods. This is the YAML way of doing things, right? You're doing the same thing here. What are you going to create using this YAML? You're going to create a deployment. How many pods do you want to run? You want to run 3 pods. Replicas, don't confuse replicas with replica set by them. Okay, replica set is not related to replicas. Replicas means number of pods that you want to be running for a deployment. And after that, this argument is basically the name, right? So in metadata, name that you see here, that is this argument. And finally, there's an image argument, which kind of is defined here in the spec containers, right? So since we are not creating echo server image, we are creating nginx image. There are slight differences, but you see that there is a pattern. And apart from that, the strategy that we're talking about so much, right? Rolling updates and recreates. This block defines the strategy. Is there any doubt, Krishna? Okay. Cool. So I think it's time to move to some hands-on stuff. So this pods and deployments and YAMLs that we saw, we'll actually go and run this on our cluster. And if you have your local Kubernetes cluster in place, maybe you can also follow along, or if not, just sit back and enjoy. Cool. So starting with pods. First thing is I need to cd into KTS manifest pods. Okay. Next, what I do is I'll apply these two YAML files. Now you see here, you can basically give more than one YAML file separated by a comma, right? That's possible using kubectl. So kubectl apply -f Redis pod and nginx pod. So what I'll do is I'll also this was running from our rapid demo. I'll just remove that. So if you see here, when I ran this kubectl apply Redis pod and nginx pod, we have two pods running in our cluster, pod nginx and pod Redis. If you look at the contents, right? This is our nginx pod YAML. And this is our Redis pod YAML. They look almost exactly the same, except for the image name and the port that is being exposed, right? So if you want to create your own pod, you can just take this template, click the image name with whatever image you have, and if you want to expose a port, you can also give a port name, right? So we created a pod using a manifest file, right? Using the declarative approach. Awesome, kubectl get pods done. Next, what we want to what do we want to see is we want to see the labels part. So if I say kubectl get pods, I can show kubectl get pods, I can show labels, right? It will just show the pods, but along with the labels this time. Now these labels are pretty important, but let's look at some examples and maybe we'll try to make sense of what these labels are. Typically in a deployment and a service, you'll see how these are being used. You can also use these labels to group a bunch of containers or pods or any resource that is running on your cluster, right? And what I mean by that is, if I want to get information about a single pod here, let's say if I want some information about this pod Redis, then in that case, what I would do is kubectl get pods and I give a pod name, right? So this is the name that I give here, and it just gives me one output in this case, not two. But what if I have 10 pods running of the same type? How do I kind of interact with them at the same time? So in that case, what you can do is, let's take a delete example. If I want to delete all the pods that have a particular label, I'll just run kubectl delete pod and I'll pass -l app equal to Redis. Okay. So what it will do is it will kind of clean up the pod -Redis. Now you see here in this delete command, I did not mention the pod name at all, right? I just gave it a label, which means it's a group operation. I can run it on a group of pods. Okay. To replica set. Yeah. Now we'll just move on. We'll change the directory. This was about pods, fairly straightforward. Any doubts, any questions about this YAML manifest kubectl command? No. Cool. So let's move on to replica sets. Okay. So in this replica set, we'll just see the YAML file here, right? So the kind is replica set. Again, metadata name, we just call it rs-nginx, just to follow some convention. For pod, we were saying pod-nginx. For replica set, will be it's rs-nginx. For deployment, it will be dep-nginx, right? So name is defined. We just define a label here. Then in specs, we want 3 replicas, which means we need 3 pods to be running. Now this is the important part, right? The selector part. What does this mean is, since replica set is a higher level object, right? It sits on top of a pod, right? And it can manage more than one pod, right? It needs to kind of ensure, or it needs to kind of keep a tab on how many pods are running, or how many pods are kind of being monitored by this replica set, right? And how does it do that? It kind of does it by grouping those pods, or rather selecting those pods based on labels, right? So if you see here, selector, match labels, right? And which labels should match. So if a pod has app equal to nginx as a label defined, then that pod will be inside or under this replica set, right? So this is the selector section which was not there in the pod.yaml. Why was it not there in pod.yaml? Because pod is the smallest possible unit, right? There cannot be anything under a pod, right? But replica set sits on top of pod. So now we have a selector, and all the pods that match this label are going to be under this replica set, right? And after that, you see that this spec kind of looks similar to your pod.yaml, where you define the container details, the container name, image version, whatever. So to apply this, what is the command that we need to run? We need to run kubectl apply -f. Okay. So before we do that, see, we have one pod already running, right? And there is a replica set YAML which has this. If let's say I want to run kubectl, how many pods will be running after I apply this command? Any guesses here? Once I apply this replica set, and this replica set is defined to run 3 pods, and there is one pod which is already running from here example. Now, when I run this command, what will be the total number of pods running in the cluster? That is the question.
3 only.
Okay, why 3? Why not 4?
It's the desired value, right?
Okay, but that pod is already running, right? It might be running from whenever. Why would, so 3 here and one here, right? Shouldn't it be 4? But anyways, your answer is correct. It will be 3, and I'll just quickly answer why it will be 3. Because this pod also has the same label, right? App nginx, and it does not have any owner defined yet. Okay, what do you mean by that is? Okay, so I mean, to explain that, what we can do is we can take a backup of this pod. So if I do kubectl get pods pod nginx -o YAML. Okay. So when I give -o YAML to a kubectl command, it will give me the actual YAML, right? So I'll save this YAML to pod nginx time t0 .yaml. Okay. This is my YAML file before I've created this replica set, and there is only one pod running. Now I go ahead and kubectl apply -f, and I give a replica set. Okay. So as you can see here, the replica set rs-nginx, it created only 2 new pods, and there was one pod which was already running, right? And hence the change, there's a difference between the naming convention as well, right? There is no random slug in this pod which is created. Okay. Whereas these 2 pods which were created by the replica set, they have a random slug, right? So now trying to understand the owner reference part, right? How did this replica set take over this pod-nginx, which was previously running on the cluster? So if I now do kubectl get pod-yaml and call it t1, okay. So I have YAMLs of this pod-nginx from before applying the replica set, after applying the replica. So let's quick dev pod t0 pod-nginx t1. Okay. Is the font visible?
Yes.
Okay. So on the left side, you see that we have T0.yaml. T0 was the initial YAML of the pod nginx which was running in the cluster. And T1 was after we deployed the replica set, right? rs-nginx. So you see that in the right side YAML, there is an extra block, right? What is that extra block? The extra block is owner references. And if you see in the owner reference, you see that it is owned by a replica set, and the name of that replica set is rs-nginx, right? So in a way, you can say that the replica set deployment has taken over this pod. And why was it able to take it over? Because there was no owner reference for this pod, right? So this is a gotcha. And if you are working in production, or if you're working, in any serious environment, make sure that you don't have any lingering pods, which, how do you say, which kind of have the same labels that you're using for your deployments or replica sets, right? Because if there are pods which are just lying around, then there's a possibility that this could happen, right? Your replica set will just try to see how many pods are running with that label and kind of supersede it. Cool. So that's about replica sets. There's one more question here now. One more trick question, I would say. So now we have 3 pods. That is fine. Consider there is one more pod.yaml that I have here, right? This is the YAML file. Now I'm doing the same stuff. I'm creating a pod, same engineer, same whatever, same labels, just a different name here for this pod. Now what will happen if I apply this? How many pods will be running there?
Total should come back to 3. Even if it deploys replica set, will scale down to 1 pod and total should be 3.
Total should come down to 3. That's correct. So let's see that. It will apply. Did you see that? So when I apply this, there's a new pod that gets created, but immediately, it goes into terminating state because there is a replica set definition for that particular label matching that, there should be only 3 pods running. So whenever you try to create this, this is the behavior that you will see. Nice. That was the correct answer. Cool. So let's clean this stuff up. Kubectl delete replica set and replica set name. This is one way to delete it. Kubectl delete and give the resource name. Another way to delete would be, let's say, if I create that replica set again. Okay. I can just give the file itself instead of manually specifying the resource name. I can also say kubectl delete -file and a YAML file, and it will clean it up. Right. So it depends. Cool. So now let's look at some deployment examples. So KTest manifest deployments. Okay. kubectl apply -f deployment. Okay. So if you check the deployment engineers.yaml, this is the same YAML that we saw in the slides, right? So there's nothing new here. We just have 3 replicas. And by replicas, we mean number of pods, not replica sets, right? So kubectl get pods. This will be 3. Kubectl get replica set. This will be 1. Kubectl get deployments. This will be 1, right? So we create a deployment creates a replica set, and a replica set creates pods, right? And you can also see and confirm that using the naming here. So the pod name is dep nginx hyphen this slug, right? C54. Where does this C54 come from? This C54 comes from this replica set, right? And this replica set gets created by this deployment. So this is the hierarchy in which things are created. Straightforward. Now what we can do is we are going to update the image again, like we did in the rapid demo, but we are going to pass an extra argument here, which is hyphen record, and we'll see why we are doing that. Okay. First, let's try to understand the command here. What it does is it does kubectl set image, right? It means it is going to set the image for a deployment, and this is the value, right? It is going to set it to 1.1.123.4. What is the current image? The current image is the current image is 1.24. Okay? And what we are setting it to? We are setting it to 1.23.4. Right? And on the right side, instead of polling the pods this time, what I'll do is I'll poll the replica sets. Okay. So there is one replica set, and I'm giving kubectl set image command. So if you see here, there are two replica sets now, right? Instead of just one, right? Although the deployments, number of deployments is still one, I can see that there are two replica sets. Why did that happen? That happened because I gave it hyphen record, right? And one of the features that Kubernetes deployment provides you is kind of rollbacks, right? So if you deploy something, if you deploy a new change, right, and things are not working, you can immediately ask Kubernetes that go back to the previous version or undo the change, right? Or it's an equivalent of Control Z on your machines, right? But how do you do that? We just go back to the document. Before we actually undo the deployment, we'll run this command kubectl rollout history, right? What it shows us is it shows us the number of versions available, right? So if you see here, this matches with the number of replica sets that we have here, which is 2, right? We have 2 revisions of this particular deployment. It also kind of logs why was this revision done, or who kind of caused this change, right? So you can see here that it is recorded that a command was run. This was the command that was executed, and that's why there's a new revision which is being deployed, right? So in this case, before we undo this, we also need to verify what is the image, right? What is the current image? So if I check the YAML file here, the image is 1.23.4, and you can see this matches the command that we gave here, right? Which we passed via the command line 1.23.4. In the YAML file, it was 1.24. In the command, it is 1.23.4, right? And now once we undo it, it should go back to 1.24, right? So we'll just quickly run the undo command. So if I run kubectl rollout undo, right? Now the interesting thing that you might have observed, some of you might have observed on the RHS, it did not immediately delete every container and deploy new containers. It did it step by step, right? One by one. Why did it do that? Because rolling updates, if you remember, right? So undo is done. It says that the deployment has been rolled back. Cool. If you go and verify the YAML file, you see that we are back to 1.24, which was the previous version. So this is one of the features that kind of Kubernetes provides. A Kubernetes deployment provides, right? Deployment object, and it is not possible using a pod, right? So if you just deploy a random pod, if it dies, nobody's going to bring it back up. If you kind of modify or tinker with it, you kind of don't track the history there, right? It's very bare bones. So deployment objects kind of help you with shenanigans like this. And how does deployment kind of get it done? It uses replica sets behind the scenes. So it's like one level on top of your replica sets. Okay. Next, what we can do is we can we can scale up the deployments from 3 pods to 10 pods, right? And now in this case, we'll try a different way. So one way we created a deployment using a YAML file that we tested. We updated the image file using kubectl set image command, right? That's also done. There's one more way of interacting with objects in Kubernetes. And in this, we'll explore that option. What is that option? This kubectl edit, right? So if let me just quickly run it, and it will be fairly clear what does this mean. So if I run, let's say kubectl space edit, what do I want to edit? I want to edit a deployment. Which deployment I want to edit? I want to edit dep-nginx deployment. Okay, so when I run this command, okay, you see that in my local editor, the deployed YAML is made available to me, right? This essentially has been fetched from etcd and made it available on my local machine. Once I make changes and I save the file, those changes will go back and be deployed inside the etcd, right? And that will be the new desired state, right? So currently, according to etcd, the desired state says that I need 3 replicas, and which is true because that is the YAML that we submitted, right, to create the object. So if I want to change this from 3 to 10, okay, I just need to change this file, Vim file, YAML file, and I'll save this. So you can see that immediately the Kube API server got into action. It instructed the kubelet to create 7 more pods. So I have 10 pods running, right? So this is one of the ways you can interact with the Kubernetes resources, and that's true for anything, right? So I can do it for, let's say, if I do kubectl get pod, and I do kubectl edit pod, and I give a pod name, right? So you see that I get the YAML for the pod. So you can do it for config map, you can do it for secrets, you can do it for services, right? Anything, replica sets, whatever you want. But again, don't do it in production unless production is already down. In that case, do whatever you want. But it's very tricky because if there is a syntax error, or if you kind of make changes that impact other services or other components of your Kubernetes cluster, it will be very difficult to track who did what, right? Because these changes are not tracked. So if you look at the rollout history, this rollout of 3 to 10, this did not get tracked, right? Because we directly kind of meddled with your Kubernetes YAML file. So be very careful before using kubectl edit in any serious environment. Okay, now next, the reason why we scaled this to 10 pods was that we wanted to test a failure scenario. Right now, what I mean by that is, in the next step, I'll try to set the image to something which does not exist. Right? I'll try to set the image of this deployment to nginx colon 1, 2, 3, 4, 5. Now this is not a valid nginx version, right? This is some random number, some random string, and we are trying to simulate a typo. It can be possible that your developers or your DevOps or your pipelines might kind of inject an image which does not exist, right? So what would happen in that case? So anybody wants to guess, if I run this, what will happen to these 10 pods? Will they start crashing? Will nothing happen? Will Kubernetes kind of make sure that it does not deploy this? What would happen here?
It will try to pull the image, face image will back off. Like one pod will go down, and when it will see that image pullback is coming, then it will roll back the change automatically, and your old number of pods will stay as they are.
Okay, one pod will go down. Let's see. Okay, one pod is already down. Second pod down. Third also down. So the good thing here is all the pods did not go down, right? And our services are still running, right? It will still be operational. And the bad thing is the deployment has failed. Okay. But let's try to understand why we have 3 pods, in this error state, right? Why only 3 pods? It could be 1 pod, like he suggested, and that's correct. In a way, that is correct, right? And I'll come to that why. Because if you see the total number of pods here, it has gone up from 10. It has gone up from 10 to 11, right? We scaled our deployment to run 10 pods, but now you can see there are total 11 pods, right? Out of which 3 are failing. So why this behavior? This behavior is there because of these 2 values: max search and max unavailable. Okay. So look at the. Let's start with max search. So whenever you release a new change, right? A deployment will try to create new pods with the new image that you have, right? But how many new pods will it create? How does a deployment decide how many new pods am I going to create, right? Am I going to create 1 at a time? Am I going to create 5 at a time? Am I going to create 100 at a time? So typically, people or companies kind of prefer to go with this percentage based, thresholds. So max search would mean 10% here would mean if I have 10 pods, right? Initially, I had 10 pods. My desired state is 10 pods. So 10% of 10 is 1, right? So it will create 1 more pod with the new image that I have. So having the total number of pods as 11 does make sense, right? So a surge of 11, right? Total number of pods will never exceed 11 for this deployment. And max unavailable means that I will remove pods 2 at a time, right? So it's trying to remove 2 from the existing pool, and it's trying to create one new pod, right? And that's how it is going to roll out the change. Okay. So this is about rolling updates. Any doubts? Any questions here? Or is it clear? Okay, awesome. So what we'll do is we saw the rolling update. We'll also see a quick demo of recreate strategy, right? Instead of rolling update. So what we do is did you see that? It terminated all the pods, and then it created all new pods in one shot, right? So step 1, delete everything. Step 2, create everything. I can show that again, right? So if I change the Nginx image from stable to, let's say, what was it, 1.24, right? So if you see, all the pods get terminated, right? This is the first phase. And in the second phase, all the pods get created, right? So recreate, as the name suggests. This is again a very special use case, and hence it is not the default way of doing things. You might want to do it in scenarios where, let's say, there are serious hardware restrictions and you cannot have any additional pod that can be deployed, or if you have very specific applications that cannot run more than one instance, right? So you either have to run this or that, so you have to kill the old first and then deploy the other, right? But very special use cases, typically you would not see recreate in in most places. Does that make sense? Cool. So we've discussed pods, we've discussed deployments, and I think we've already We're already 2 hours into the session. Do you guys want to take a quick 5-minute break or something? Or should we continue and wrap this up?
If people are like, you know, if people actually want to take a break, like they just have to, like, you know, give a show of hands. Like I think you've covered like mostly all of it. Like
yeah, I guess only the services part is left.
Yes. And it actually just depends on the people. Like Abdul, would you want to also like take a break right now?
No, I'm fine. I can continue.
All right. Like, what about you guys? Like, if you guys want a break, like you can just write it in the chat. Otherwise, you guys can just like give a go ahead. Then Abdul would continue with the entire keynote.
Yeah, I guess let's continue. Nobody needs a break, or maybe people are already on the break.
All right, it's okay. Like, just continue. It's cool.
Sure. So before we do the services hands-on, let's talk a bit about services and why do we need services in Kubernetes. So the Kubernetes networking model kind of expects that every pod is going to get a unique IP address, and every IP address will be reachable from every other IP address, right? So essentially, no matter where your pod is running, it will get an IP, and no matter where the other pod is running, these two pods will be able to talk to each other. Now, this should be good enough. You can argue that I can just use this IP address and communicate, but that's not how it would be. It happens in real world, right? Because pods are ephemeral. Pods might come and pods might go, right? So in our example, when we scaled from 3 pods to 10 pods, right? So in state 0, time t0, there were 3 unique IPs for this particular service. And at time t1, when we had 10 pods, we had 10 different IPs to reach this service, right? So if you are a client and if you want to access the service, it becomes tedious, it becomes painful to keep a map of all these IP addresses, right? So you need some mechanism to get a list of IPs for your pods every time, right? And they should be kind of updated in real time, because if not, then when you scale down, those IPs are going to be lost, right? And all traffic that is going to those will be dropped, or worst case, it might go to some other pods, right? Because the IPs could be reused by some other pods which have come up. So to solve the problem, Kubernetes has come up with this service, the notion of service, right? A Kubernetes service is a virtual IP on top of pod IPs. We'll not go into the depths of virtual IP here, but think of it as a virtual load balancer, right? If you work with any kind of load balancer, ELB, ALB, NLB, just think of it as a single entry point which listens, which has a listener on one end and it has target groups on the other end, right? So you can define a listening port and you can define the target port, right? So a typical example would be your website, which is running, which is exposed using a load balancer, will be listening on port ATN443, and it might be forwarding that traffic to your container, which is running on port 5000, right? So that's how a service would be configured, right? A service again uses selector labels, just like replica sets. We'll see a YAML example as well for service. And there are typically 3 types of services. Cluster IP is the default one. If you don't define the type, you get a cluster IP service type. And this cluster IP service is accessible only inside the cluster, right? So for example, you have a Python application and a MySQL service, both running in the same cluster, and they want to talk to each other. They would typically talk using a cluster IP, right? Because Kubernetes by default also provides a DNS server, out of the box for you, and It's known as service discovery side of things. But for now, let's just assume that whenever you create a service, you can access it using the service name, right? Second is a node port. Node port is typically used when you want to expose your service, right? If you want to expose your Python service to a component which is running outside of your cluster, it may be within your network or it can be out of your network. But if you want to expose a service outside of your cluster, you use a node port, and the way you would access it is you would give the node IP and you would give the node port, right? And hence node port. I mean, pretty straightforward. But this is not very common. You would not directly use a node port, although a lot of components that you'll use in future might be using node port. But you would not be directly dealing with a node port. Typically, you would be dealing with a cluster IP or a load balancer service type, right? So we'll talk about them more. So the service type load balancer, as we saw in the demo as well, if you want to expose your service to the internet, you would use a load balancer service type. And if you're running a managed cloud Kubernetes solution, you would also get a cloud controller manager. And whenever you kind of just create a service and say type load balancer, a new ELB will be created for you, and the service will be accessible behind that ELB. Let's try to understand that using an example. Let's say we have a cluster, a node, and we have 3 pods running on that node. Pod 1 and pod 3, they belong to the Nginx group, and pod 2 belongs to the Echo server group, right? The first way would be can directly access these pods using the IP address of the pod, right? Because every pod has a unique IP address, right? But we discussed the challenges there. Who is going to keep a track of the number of IP addresses for Nginx? Because today there are 2 pods. Tonight there could be 5 pods, and tomorrow again there'll be 2 pods, right? So every time this change happens, how is the end user or your customer, right, your client going to know? It's a difficult problem. So to solve this problem, what we have is a service, right? So this block in between that you see here is a service, and what you do is you say that I want a service with the name svc-nginx, and all the pods that have this particular label, right, should be the backend for this service. So if today you have 2, tomorrow you have 5, then you have 100, then you have 2 again, doesn't really matter. As long as this service object exists, right? And your clients can directly use the virtual IP created for this service object, right? So this service object, as long as this service exists and you don't delete it, this IP is not going to change, right? And this name is also not going to change. So it becomes really convenient for your clients to interact with each other, right? Without worrying about the underlying details about where the service is running, what is a pod IP, and what, right? So at a high level, this is the overview of a service. So let's just quickly see some hands-on stuff here. So before we deploy, we'll go through the files that are available here. So if you see in the service directory, there's a deployments.yaml file. And now what we're doing is in the same YAML file, we are creating 2 different deployments. I mean, we could have created different files as well. I could have created deployment1.yaml and deployment2.yaml. But just to showcase that this is also possible, you can club in as many YAMLs as you want inside a same file, and Kubernetes will kind of take care of creating all these resources. So let's just quickly see what are the 2 YAMLs that we are creating. We are creating Nginx and using the Nginx image, and we are creating Echo server using Echo server image. Both of these examples we've seen in the demo, right? And similarly for the service YAML, you see that we are creating 2 services here, right? Both of these services are cluster IP type. Okay. Actually, what I'll do is I'll try to just create an EKS cluster to give the load balancer demo, and if it comes up by then, awesome. Usually takes time. Yeah. So if you have a EKS cluster, it would be good to kind of give a load balancer demo there. So yeah, coming back to this service YAML, we'll just apply these files now. kubectl apply deployments.yaml. So it created 2 different deployments, and kubectl apply service.yaml. Okay, so if I do a kubectl get svc, I see that there are 2 services freshly created 7 seconds ago. One is svc nginx and one is svc echo server. So now the question is, how do I test this? Because cluster IP is a service, as we discussed, which is accessible only inside the cluster. So now if I want to test this, how would I do that? If you remember, we ran something called as kubectl exec. So we can run kubectl run command where we give an image name, and to the run command itself I'll pass -it, right? So instead of kubectl exec, which you use to exec into an existing pod, into a pod that is already running, I can directly give kubectl run, and what it will do is it will create a new pod and also exec into the pod for me, right? So if you see, I get a prompt here, and to verify, if I just check pods here, I see there is a new TMP pod which has come, right? Which is the name I've given here. This is just a temporary pod, and since I've given a -rm argument here, once I exit this pod, this will get automatically terminated, right? So this is a good hack to kind of debug something inside a running cluster. So what we came here for is we came here for testing the service objects that we created. So we need to try to access these services from inside the cluster. So if I do curl svc -nginx, right? Awesome. So I can access this nginx here. If I do curl svc echo server, great. This also works, right? And the same thing will also work if you use the pod IP addresses, right? So if you see the echo server pod IP, if I pick one of the individual pod IPs, this should also work, right? Awesome. But as we discussed, right, if this pod gets killed, now there's one pod that I killed a pod, right? And it is going to recreate. So the IP which was there, 172.17.0.6, so in this case, you got the same IP, but it may or may not get the same IP every time, right? I guess here there's not enough load. So in a dynamic environment, directly using these pod IPs can be painful. But then the question would be that how does this service get to know which which all IPs pod IPs are there, and how does this service kind of do that mapping? For that, I guess you have something called as endpoints. Again, this is something which you might come across very rarely. You might not have to deal with these endpoints directly, but every time you create a service, right? Cluster IP, node port, load balancer, whatever, any service that you create, there are endpoint slices being created, right? And if you see here for echo server, there are 3 different endpoint slices. So there are 3 different IPs, which means there should be 3 pods running. If there would have been 10 pods running, you would have seen 10 IPs, right? And for Nginx, we just have 1 pod running, so you just see 1 endpoint slice here. So this is like as I told you, the backend target groups, right? So there's a listener and there's a target group. So these are like backend targets for your service. These 3 IP addresses. Cool. I guess that's pretty much it from my side. The load balancer demo, we might have to wait for a while, I guess. This EKS cluster is coming up. In the meanwhile, if you have any questions, if you want to try out these things on your own, if you're facing any errors while trying these commands, maybe we can use the time to kind of discuss that.
Any queries, any doubts, all of them would be entertained. You guys just have to like unmute yourself and like just ask like whatever you guys feel like.
Cool. I mean, if there are no questions, then this is the final slide where I've compiled a list of resources that you guys might find helpful as next steps, from here. So first is
Guys,
container.training.
take note of this because it's like usually very hard to take a screenshot of these resources when you get them for free. So yeah, please help yourselves.
Yeah. Yeah, I've given a link to these slides in the Git repo as well. So you can access these slides whenever you want. So I guess that should not be an issue. But these are some important resources, right? So there's container.training. Some of the slides that I've created here have been referenced from there. But if you want real in-depth, courses, I would strongly recommend I would strongly recommend visiting container.training. They have like really, really good stuff. They have slides as well as videos. Next would be cloudyuga.guru. So Nipendra, I guess, who was the host of this event, he runs this cloudyuga guru, and you'd find a bunch of hands-on labs and courses, on his website. So do give a visit. The utility that I'm using on my command line is called K9S, right? The one on the right here. It's pretty handy when you're working with Kubernetes. So if you want to learn more about it, just check k9scli.io. Apart from that, the terminal that I'm using is Powerline Power Level 10K, and there are some Kubernetes open source contribution links here in case you guys are interested in open source, contributing to open source or attending open source events. So do check out kubernetes.io docs and buy more tickets to Kubernetes Community Days Bangalore workshops on tickets.kcdblr.com.
Well, nobody could have said it better. Again, thank you so much, Abdul. By the way, like, would you be able to show the load balancer demo?
We have already covered that in a way in the rapid demo section. But if you guys are okay to wait for, I don't know, it might take 3 to 5 minutes, we can do that.
I mean, what gives? I'm sure people would be there. It's no big deal.
We can do that. We can do that using Minikube tunnel as well, like we did earlier. So in the meanwhile, that comes up. Let me just show to you once again here. So the Minikube tunnel. Now we have to do again. We have to run Minikube tunnel because we are not running on a cloud provider, and we don't really have an actual load balancer which can be provisioned, right? So we need some kind of workaround to get this done. So I set up Minikube tunnel. I pick, let's say, a service Nginx, and in that I'll just go and change the type. So the type currently is cluster IP. If I just change it to load balancer, you see that there's an external IP which gets assigned, right? Which was not there earlier. And now I can access it using a local host. So this is my Nginx pod being exposed through a load balancer service pipe via Nginx.
All right, nice.
And the same thing in the cloud demo, what I wanted to show was this same change that we do here it would create a new ELB in your cloud. So that's it. I guess it's going to take time. Unless folks are interested, I think there's no point.
Well, I'm sure people would wait for it. It's no big deal.
We can give the feedback forms, right?
Yes. That's what I wanted to say. Like, folks, please fill up the feedback form. Like since we'll be waiting for a while. So I'm gonna be posting the link on the chats right now, and please do fill it up like right now. I've like sent the link. Please do check it out. And well, again, for I don't know, maybe like on the ending note, I'll say again, thank you so much, Abdul. That you've like at least shown the basic ropes to all the people who were present here, right? And I mean, to everybody out there, like I would like to say this that people, this technology, it's quite old, but also at the same time, it's like I mean, like right now, since we are like shifting from the monolithic infrastructure to like Kubernetes and all, so this can actually open many different like opportunities for all of you guys. Like all that you have to do is like spend some time with this technology and like learn as much as you can. And again, like KCD Bengaluru is like giving you all an opportunity to basically like participate in all these workshops like preceding the main event on 2nd and 3rd June. And I hope you guys like register and like register for more like such workshops at tickets.kcdblr.com. Like I'll like post that link as well. Just give me a second. Uh, so yeah, basically it's just that. I hope you guys found this session like interesting and like I hope that you people learned something, because I think uh, any speaker would like want like the audience to at least find something like informative in the uh, keynote, and I hope that you guys enjoyed it, and I hope that you guys join us again like on the next keynote, and I hope that you guys buy tickets for KCD Bengaluru. That's all, and I'll just post the link.
Cool. Thanks, Sunit. Thanks a lot, guys.
All right, fine. By the way, guys, please, like, I hope you guys have like filled up the feedback forms. Yeah, that's all. All right, then. Thank you so much again, Abdul. It was nice having you.
Thank you all. Thank you, Karim, for the session.
It was nice.
Thank you, Abdul, and thank you, Karim.
Yeah, thanks, guys. Enjoy your weekend, and feel free to reach out to me or anyone from the community in case you have any follow-up questions. Bye-bye.
Yes, guys. That as well. Like, please,
Yeah.
like, if you guys ever have any doubt, like, please reach out to Abdul, like, using his socials. He's on LinkedIn as well as he's on Twitter. You guys can check out his socials on tickets.kcdblr.com itself, under the keynote section. So yeah, again, guys, please do like if you guys have any doubts whatsoever, please do go and like ping. That's all.